Hi everyone, and welcome back to the channel. Today, we're diving into a topic you probably didn't expect: DevOps and PLM. Now, you might be thinking, wait, isn't DevOps something for software engineers? What does it have to do with designing cars, robots, or consumer electronics? Actually, a lot. DevOps, with its principles of continuous integration, automated testing, and rapid iteration, is slowly, but surely, making its way into product lifecycle management, or PLM. And it's changing how we design and build physical products from the ground up. In this video, we'll walk through how DevOps can be adapted for the physical world, from design to validation to delivery, and what that means for the future of engineering. Let's start with a quick refresher on PLM. PLM stands for Product Lifecycle Management. It's a structured approach used in mechanical, electrical, and electronic product development to manage everything from initial concept and design to prototyping, testing, mass production, and even end-of-life recycling. Traditionally, this process has followed a waterfall model, a sequential, department-by-department workflow. Design first, then pass it to prototyping, then testing, then manufacturing. It sounds organized, but in reality, it's extremely rigid. Imagine this: you're working on the battery system for a new electric vehicle. After spending weeks designing the layout, the mechanical team comes back 3 weeks later and says, "Hey, there's not enough room in the chassis." Now you've got to scrap and redo your entire design. One minor change becomes a domino effect, impacting every team down the line. This is the bottleneck of traditional PLM: slow feedback loops, poor interdepartmental visibility, and high risks when making late-stage changes. Now let's flip to the software world. Software teams figured out a long time ago that waiting until the end to test everything is a recipe for disaster. That's why DevOps was born. DevOps, a blend of development and operations, advocates for tight collaboration between developers and IT ops, CI/CD, continuous integration and continuous deployment, automated testing pipelines, infrastructure as code, IAC, end-to-end observability and monitoring. These practices enable teams to ship faster, with fewer bugs, and much greater resilience. Think of how frequently Facebook or Amazon push updates, sometimes thousands of times a day. Or how Chrome updates silently in the background without interrupting your work. That's DevOps at work. Tools like Jenkins, GitLab CI, and GitHub Actions have turned what used to be a manual release process into something automated, reliable, and scalable. And here's the exciting part: this exact model is now being adapted for hardware development. So, can we apply software's high-efficiency DevOps model to hardware, electronics, and complex mechatronics systems? Absolutely. And in fact, we should. Let's break down how this works. CI/CD plus systems engineering. In physical product development, systems engineering integrates multiple disciplines: mechanical, electrical, embedded software, etc. Applying CI/CD here means each module push triggers automated integration tests. Simulation and system-level validation are continuous. Updates from different teams sync into one streamlined pipeline. For example, a German autonomous radar company set up a CI pipeline that automatically validates full vehicle behavior whenever sensor parameters are adjusted. Or imagine developing a smart vacuum cleaner. The motor, navigation, and battery systems are developed by separate teams. DevOps tools allow every code or design change to trigger an automated end-to-end system test, ensuring nothing breaks down mid-integration. TDD plus digital twins. Test-driven development, TDD, is another pillar of DevOps. In software, it means writing tests before writing code. For physical products, we now have digital twins, virtual representations of real-world systems. This enables parametric modeling of every component, real-time feedback from sensor data, iterative testing in simulated environments before committing to hardware. Siemens and Airbus use digital twins to simulate entire aircraft behavior under extreme conditions, reducing physical test flights and accelerating certification timelines. Volvo crash tests its car designs thousands of times in virtual environments before building a single prototype. This reduces both R&D costs and time to market. Think of it as unit testing and system testing, applied to reality. Of course, implementing DevOps in PLM is not without challenges. Technical barriers. Hardware tests aren't real-time, they require physical builds. Simulations, especially FEA or CFD, are compute-intensive and complex. Integrating CAD, CAE, and PLM platforms is messy and tool-dependent. Organizational challenges. Multidisciplinary teams aren't used to continuous delivery models. Many companies favor stability over rapid iteration. KPIs often don't reward DevOps-aligned behaviors. Many companies spend months just aligning version control, building test harnesses, and reorganizing teams for better collaboration. DevOps for PLM isn't just about tools, it's about rethinking engineering culture. PLM systems are evolving from static data vaults into live, continuously integrated validation centers. AI-augmented decision engines that predict risk and suggest improvements. Central threads connecting CAD, CAE, MES, ERP, all in the cloud. And DevOps is the backbone of this transformation. Every design change triggers automated simulation. Anomalies feed into real-time monitoring dashboards. Version trees allow rollback, comparison, and traceability across time. At one smart manufacturing firm, every battery module design change for a new power tool triggers a simulation pipeline that evaluates thermal management, generates a report, and stores it in the PLM system for engineers to review. No emails. No delays. Just data and action. DevOps is no longer exclusive to software engineers. It's steadily making its way into the world of hardware, embedded systems, and manufacturing. And for good reason. With DevOps, traditional engineering teams can expect higher agility, more immediate feedback, stronger traceability, better risk control across the entire lifecycle. As cloud-native CAD, digital twins, edge simulation, and AI-driven validation mature, DevOps for PLM is becoming more than just a concept, it's the new standard. If you're an engineer, product manager, or PLM architect, now's the time to ask yourself, is my team DevOps ready? Have you seen DevOps principles used in hardware development? Or are you trying to bring it into your workflow? We'd love to hear your story. Until next time, thanks for watching.